respiratory systems. We say we are in the physiology class, mainly we talking about functions. So mainly we talking about the respiration systems, its functions. So respiratory systems, their functions, if we simply to say, basically is the gas changing, gas exchanging. What means gas exchanging? So basically take in oxygen and also relieve carbon dioxide. So that's it, basic function. And certainly they have some other functions. They can regulating blood pH. So basically that's kind of form like a follow carbon dioxide, how much they can relieve. So basically that's the form, travel in the blood circulation and finally relieve in the lung. And that's basically by the amount, and then they regulate pH. We still know our normal pH should be maintained between 7.35 to 7.45, a little bit unlikely side. Middle J7, middle J7. So that's the respiration systems. That's we talking about. And then some other functions. Some other functions. We know like the nose relationship with our respiration systems by Western medicine. So the nose functions, smell functions. So we have some special kind of cells can receive the informations. That we call receptors for the smell. So that's they have some smelling functions, and the nose have some other functions, filters for the air. So we know in the air we have a lot of pollutions and also some pathogens. So basically the nose is the first part air going of our inside body. So truly they have some filters functions. And also producing the sound. So the sounds producing, we have voice box that's right between our sound air and the trachea. And also relieve a little bit of water and heat from the respiration. It's not a big amount. It's not a big amount. So that's some basic function we're talking about our respiration systems. So that's the basically respiratory systems and its functions. So we say respiratory systems, the mainly functions is gas exchanging. Then let's talk about some detail about the gas exchanging part. So basically, gas exchanging, we call it respiratory. So that's basically including three parts. One part we call pulmonary ventilation. Pulmonary is the medical word, is the lung. Ventilation means the gas go in, go in. From the outside, the air, and go into the lung. We know the basic unit of the lung is the alveoli. So that part, we say pulmonary ventilation. And we also including, we name it external respiratory. So still means happens in the lung. So this part of the gas changing is between the alveoli and to the blood vessels. The tiny blood vessels in the lung we call pulmonary capillaries. Capillaries, just the small blood vessels. If they are in the lung, we call it pulmonary capillaries. So that's the second part. Second part. And the third part, we call it internal respiratory. Internal means in the tissues. The gas changing in the tissues. So basically in the tissue part, from the blood circulation from the capillaries and sending to the tissue cells. So that part we call internal respiratory. So that's we say gas changing or respirations including three parts. We will talk about the detail one by one later. We just got some basic picture here. So generally speaking, that's the respiration systems here. So we say the first step start from here, and then all the air go in, sending to the lung. Certainly both sides of the lung. That's the first step. First step. Second step, it happens in the lung. Happens inside the lung. Inside the lung, we have lot of small, like a ball in there, we call alveoli. And close to that air, I just make a one enlarging here. That's alveoli. And around it, some blood vessels. So basically, the air changing from the alveoli to the blood vessels, and from blood vessels to the alveoli. That's the second step. Certainly, in this part, the oxygen moving from the lung go to blood vessels or capillaries, and the carbon dioxide moving from blood vessels to the lung, to the alveoli. So that's the second step. And then follow the blood circulations. Follow the blood circulations. They will go to the heart first. Yeah, like we're talking about circulation systems. They sending go to the heart. Yeah. Left side of the heart, and then sending through the big blood vessels. Yeah. And sending to the tissues. Yeah. So tissue part, we call it small, tiny blood vessel there. Still capillaries. Yes, still capillaries. So in that part, the gas changing. Yeah, the gas changing. So still, like I make enlarging here. That's the capillaries. And enlarging blood vessels here. And the blood flowing this way, artery coming this way. So relieve oxygen, go to tissue. And take carbon dioxide, go to blood circulation. And then the blood through the vein go back to right side of the heart. So in other words, the respiratory systems is more close relationship with the circulation system. Without blood circulation, basically, respiration systems will not work. So these two systems helping each other and working together. So that's the basically chart about our respiration systems. So we say respiration systems, we can simply separate with two parts. One part is the organ part, the lung. Another part is the tube. Is the tube. So the tube will have the bigger one and then branched to small one, small one, small one. But upper part, yeah, upper part, basically more bigger, including the nose, including the third area, including the larynx area. So all these parts together, we call upper respiratory tract. So people pretty easily got the infection in this part because it is more superficial. And the lower part, yeah, below the larynx is all trachea. And then we have bronchial there. Like usually like a picture like this. And then they got smaller, just like an opposite tree. Yeah, just like an opposite tree in there. That's the bronchial tree. So that part belongs to low respiration tract. Certainly, we say we separate the organ and the tract. And the inside the lung part, they are mixed together. They are mixed together, basically. Some bronchi tree in there, and some alveoli in there. So that's basically anatomy of our respiration system. Then we go to different parts. We're talking about their functions one by one. We say respiration system start from the nose. Inside the nose, we have cavities. So that's the beginning part, the air go inside of the bodies or opening part. So when go inside the nose, we have cavity there. So we have two separate space and then two cavity there. So basically this part, their functions is not only for air passing through. They have their special functions. We say inside the nose cavity, they're covered by the mucosal membranes and a lot of blood vessels inside. That means a lot of blood circulation go to there. What's that function? Truly, they can breathe heat in there, follow the blood circulation. We say blood temperature is a little bit higher compared with the superficial body temperature, about 1 degree, 30 degrees higher. So certainly when blood circulation go to there, it bring more heat go to there. And also moistening to the nose cavity. So we know inside the blood, mainly part is the fluid. And the cells in the nose cavity, they can secrete a big amount of the fluid, especially when people getting sick. Yeah, lot of discharging. But normally, there is still secretion some amount of the fluid, promotion some moisture for nose cavity. So then, what will be happens? What will be happens in the nose cavity? So the first function is the filters function. Filters function because inside the nose cavity, we have a lot of small hair in there, like a body hair. So these kind of hair in there can blocking some like passengers or pollution things like dust. So that's the first function of nose cavity, filters. And then nose cavity have another functions, warming, warming function. This kind of warming is coming from the blood circulation in the membrane there. It's a warming air. So why we need a warming air? Because outside air usually is cold. So even in the summertime, most time, like there are about 20 or even 30 degrees, they still low compared with body temperature. So we say body temperature is 37 degrees. So outside air go in, and certainly in the winter, even more colder. So sometimes it's a kind of -2 or -10 or even -30 some air. So that kind of air, so cold, if directly go to inside of lung, truly damage lung function. So we need a warming first, warming the air. So that's why, like with respiration, we through the nose. We are not encouraging the people like respiration through the mouth. Mouth have 8 special functions, but mainly we respirations through the nose. So Y is for bitter, Y is for warming. Another one is can get some moisture. In case some so dry air go to inside of the lungs. So that's some function relationship with the gassing, exchanging. And certainly our nose have another special function. People can smell it because we have special kind of cells in the nose cavity. And that kind of special cells have function for smelling. So that's the nose functions or nose cavities functions. So that's just the picture for anatomy here. From the nose, basically a big part is the cartilage. And certainly on the root of the nose, we have bone part. So air go in from here, certainly. Here is the inside nose cavity. Inside the nose cavity, you can see basically we have 3 kind of bump here. And that kind of bump increase the superficial of the nose cavity. Means we have more blood vessels go to there, more blood supply go to there. So that's more warming, more moisture function in there. So air go in and passing through here, and then go to the throat. And in the nose part, we have another anatomy structure there. We call it a sinuses. What means sinuses? Yeah, what means sinuses? Sinuses is just some space located inside of the bone, of skeletal bone. That's we call sinuses. And the sinuses connected with nose cavity. They have open there. And they also cover with mucosa membranes. That kind of mucosa membranes is connected with nose cavity mucosa membranes. So if any inflammations or infections happens in the nose, it's pretty easily go to sinuses because they truly connected each other. So we have 4 pairs of the sinuses. They are the same name with their location in the bone. They are the same name. So that's basically we say we have some sinuses. But what are they working? Why we need sinuses? So basically, they're working for the sounds. Yeah, we're working for the sound, like speak or singing. Because there are big space in there, it makes sounds bigger. Just like if we go to a totally empty room, and then we yard there, look like a sound is much bigger. Compared with like in the room, lot of people inside, the sounds will be absorption by the materials, by the people. So that's the sinuses, their function. Truly, clinically, they may cause some sick or illness. We say because they open to the nose cavity. When nose have infections, they will easily get infection there. So that's the picture show us 4 pair of the sinuses in front of frontal bone. We have 1 pair there, both sides. Yeah. Let's go to side like this. And then we have another bigger one, maxillary bone. Still more in the superficial. That's the location, sinuses. Basically, these 2 sinuses, it is bigger and easily cause the trouble and with easily examinations because it is located in the superficial of the body. Another, yeah, we truly have another sinuses, another 2. It's more deeply, it's more deeply. They still cause the problems, but let it be hard to checking from superficial. But totally, truly, we have 4 pair of the sinuses, 1 on each side. So that's the nose part. Then we move into the third part. Medical words also call it pharynx. So basically, in third part, mainly is the muscles there. And mainly is the air passing the root. And it also working for digestion systems. Like we taking food, go to digestion systems. So throughout part we separate with 3 parts. Behind the nose, we call nasopharynx. Behind the mouth, oropharynx. That's basically just the medical words here, nose and mouth. And behind the larynx area, laryngeal pharynx. So that's pretty commonly medical words, pretty long, but they compose few parts. You can try to separate to remember it and understanding it. So that's we say behind the nose part, behind the mouth part, and behind the larynx part. So third part, we don't have too many other functions. Just passing the root, the air, and passing the root for the food. Then we're talking about the larynx part. Larynx part, they have their special functions to make a voice. We also call it voice box. So it's located between pharynx and the trachea. Or we can say it connected pharynx and the trachea. And they formed by the cartilage. And that's the little bigger cartilage in there. And especially for the male, they go to frontal part of the head, of the neck. Sometimes you can touch it or looking there. Now sometimes we call it Adam apple. That's basically coming from the larynx cartilage. And we say the cartilage there is bigger in the male and a little bit smaller for the female. And so inside of the larynx or inside the voice box, we have vocal cords. The function of it make sounds, make the voice. So that's basically the air flowing out, coming from the lung, and especially passing vocal cord area, and then make the voice. So that's why we can speak. So certainly if you put your hand over your voice box area, you can feel the vibration there. And the different size of the larynx make the sounds little bit different. That's we say male and the female, the voice is different because men's larynx is bigger than females. So the voice for men is more lower in pitch. And certainly for female is more higher in pitch. And the way making sounds, certainly more important part is the voice box, but also nose cavity, sinuses, and the pharynx. They are working together. That's like a sound chamber in there. And then people can make bigger sounds. So that's just the anatomy picture here. Show us some cartilage. They form the larynx, and the lower part connected with the trachea cartilage. Then we're talking about glottis and epiglottis. So the space, the space between the vocal cord we call glottis. So we can see the pictures. So that's the vocal fold here, or vocal cord, the same meaning. And then we're talking about usually they have some space between. Usually they have some space between. But when people like cough, before it cough, they will be closed and then suddenly open. So that's basically they can moving and make different sounds. They moving ways different. Sometimes it's wider, sometimes it's more thinner space there. But that's generally the picture about a voice box here. So we say about it, we have another cartilage. It's leaf-shaped cartilage, can cover it. Because they have space there, we call it glottis. And we cover it epiglottis. Why we need this kind of cover? So we know salt air, they're working for both respiration systems, air passing, digestion systems, food passing. And we also have two tubes below. These tubes, trachea, go to the lung. Another tube behind it, thus go to the stomach. So we need to separate air go in, go to the trachea, and our food go in, go to our stomach. So how we control it? Write this cartridge. Write this cartridge. So this cartridge, they can move in. They connected with the root part of our tongue. So when we're eating something, and especially when it's swollen, the tongue will moving backward. When tongue moving backward, they moving this cartridge backward also. So that's truly form a cover for the trachea. And then our food will go to behind trachea, another tube go to digestion system. And the normal situation, it will be open, allow the air passing in and passing out. So that's basically it happens in there for Larry's part. For Larry's part. So that's basically, and certainly inside of Larry's part still have pretty tiny small kind of hair in there. And if something go in, that hair can move in the dusk, go to outside part, like by cough, by sneezing, by blowing the nose. So that's still kind of filter or cleaner in there. And the voice code. So inside, we say we have some tight part, mainly is fabric in there, and can make it a voice. Can make it a voice. So we have false vocal cord and the true vocal cord. What that means? What that means? So basically, this part we call true vocal cord, both sides, and beside it is the false vocal cord. Mainly make the voice in the true vocal cord part, but they need help each other. So that's we say make the voice by the vocal cord and the different kind of shape in there. The sounds will be different. Thus, we talking about the pitch here. Pitch is controlled by the tension of the vocal cord. If it's more tight there, so basically vibrations, the sounds passing through is more faster. The pitch more higher. And certainly opposite, if decrease the tense in there. Thus will be vibration is slow and the sound pitch is lower. So that's basically, and it affected by different genders, like different kind of hormones inside. So that's we say in the male, the vocal cord is more thicker and longer. Thus make a sound more low frequency and low pitch. And in female, the vibration there is more faster and make the sound is more high. So that's the high pitch in there. So that's normally when we breathing, it's totally open there, totally open. So sometimes more narrow, sometimes it's more closed. It's just when we're making sound. So that's basically. Then we're talking about the trachea. Trachea is a little bigger tube. Upper part connected with the larynx. Lower part go to the chest. Basically, it's still above the heart. And then they bunch it. So it formed by the cartilage and shaped like a letter C. So what means the shape look like letter C? So here is the trachea. That's the cartilage formed. And that's the anterior part of the body. That's the posterior part of the body. Then you can see behind it, behind it here, still connected, still connected with the cartilage. But this part is not cartilage. This part is the muscles, muscular. So basically, smooth muscles in there. So it makes it like some changing possible happens. Like a normally cartilage holding the space there, they will not able to totally close. And the muscular in here. And the posterior part, we have another tube. Esophagus. Esophagus is a tube connected with the pharynx, with the stomach. That's the food passing the room. So that's the muscular in there. So when we respirations, so basically we're holding the space inside of trachea. But when we're eating, the muscles can be go to inside of the trachea a little bit and allow the food passing through. So that's the that part, like our respiration systems and digestion systems, they connected. And then trachea divided into two branches. We call it pulmonary branches. pulmonary bronchi. There go to the lung. Right side, right side is more large. And the small side, left side is a little bit smaller. And the angle there on the right side, little bit bigger angle compared with left side. Let's see if we have a picture here. Yeah, let's see this picture here. We say that's the trachea. That's the bronchi. So bronchies, we have different levels. That's the first bronchi, just coming from the trachea. We call it a pulmonary bronchi. Certainly on the right side, we call right pulmonary bronchi. On the left side, we call it left pulmonary bronchi. So basically, it's this part. So you can see the angle here a little bit different. Yeah, a little bit different. The angle here compare angle here. Right side is more bigger. Left side a little bit smaller. So that make like if something falling down to the trachea, it's pretty easily go to the right side because the angle there. So that's about the trachea. So that's we say if something falling down to the trachea, mostly happens for children. They place something and then put it in the mouth, and then they try to speak, and then something falling down to the trachea. So normally inside our trachea should be empty. Yeah, should be empty. That's allow to the air passing only. No liquid, no food. Any kind of liquid or food go to the trachea will cause the people severe kind of cough. And connected with trachea, connected with trachea is the bronchi and the bronchiolus. We say that's the bronchitree in there, bronchitree in there. So bigger one, bigger one, we call it bronchi. So trachea truly divided with two bronchi and then go to inside of the lung. And the right side, right side, like we say already, is larger in diameter. Left side is smaller in diameter. But left side angle is smaller and right side angle is more bigger. So that's we say, if something follow, go to the trachea, it's easy go to the right side of the bronchi or right side of the lung. After, like they go inside the lung, they go to more smaller. So we can have secondary bronchi and even more smaller. So, but the smaller, then we call it bronchiolus. Have few branches, then we call it bronchiolus. So still bunched, go to more smaller again. The smallest one, smallest one in the bronchi tree. That's the smallest tube in there. We call terminal bronchioles. So that's from the pulmonary bronchi, and then changing to the smaller and smaller and smaller. That look like a tree in there. Usually we call it a bronchial tree, And the bronchi, like a pulmonary bronchi, go to inside the lungs. That area we call hilus. That's not only the bronchi go in to lung in that area. Blood vessel also, nerves also go inside the lung in that area. So like the picture here. So this part and this part. So hilus in the medical words, just like a open or door in there. Just like an open or door in there. These words were not only used for the lung. Later on, we still use for like the kidney. Still, blood vessel passing there, nervous sponge passing there, and other tubes passing there. So that's the means hilus. So that's basically upper part of the respiration systems, including we start from the nose, and then we talking about the throat and the larynx and the trachea and the bronchi and the bronchiole. So now we're moving to the lung. That's the mainly important part of our respiration systems. We say that's the external respiration happens. And basically in that area, we take in oxygen and release carbon dioxide. So everybody have two lungs. They are located in the chest cavity, thoracic cavity. On the right side of the lung, we have three lobes. Left side is two lobes. So changing the words here. Yeah, two lobes in the left side. And when bronchi go in the lung, we say that's at the hilus part, and immediately bunch it again, subdivided, and then again. So make it smaller, and smaller. And then we say we call it bronchiole. So basically the bronchs, it formed still small piece kind of cartilage in there and formed the wall in there. Pretty similar like trachea. They holding the air passing through, but they just little bit smaller there. So go in and go out easily with the cartridge holding there. But when they got more smaller and more smaller, the cartridge is less and less. So finally, in the bronchioles, there's no cartridge anymore. So water in there, smooth muscles holding there. So smooth muscle holding there, it controlled by the automatically nervous systems. But also clinically, when some troubles happens, like people asthma, what will be happens? Like smooth muscles holding the bronchioles there, normally no trouble. Air still easily passing in, go out. But people asthma attacking, basically the smooth muscles is contracted there, make the passing route very, very narrow. So that's why people got severe kind of short breath, because are not be structures in there. It's not like a cartridge holding there. Cartridge holding there, they will not changing the size, but the smooth muscles holding there, truly changing the size. So that's our lung. So that's our right side lung. We can see three lobes there. Three lobes there. That's the upper lobe here. That's the middle lobes here. And certainly another one is the lower lobes here. On the left side of the lung, we have two lobes. That's the upper lobe. That's the lower lobe. They don't have middle lobe. And the separate lobes with lobes, they have some like a fabric in there. So that's the basically our lung. And inside the lung, inside the lung, we can see the bronchial tree get more smaller. And then the ending part, each of the ending part, it just look like this. Like a kind of groups in there. Basically, it's the air sock in there. We call it alveoli. We call it alveoli. So that's truly air changing happens part. Alveoli. So that's the ending part. Each of the smallest bronchial tree. So we have million of the alveoli in there. So that's connected with terminal bronchioles. And then like a group kind of air sacs there. It just look like a growth. So this kind of sac, we call it alveoli. That's formed by single cells laying there. That's epithelial tissue in there. So this way is easily air passing, like a gassing passing through from the blood circulation to the alveoli, from the alveoli to the blood circulation. So we have millions of the pretty tiny small capillaries kind of alveoli in there. So let's see the picture here. So that's the terminal bronchioles here, and then connected with alveoli here. You can see that's just a single cell line in here. Then blood vessels. Yeah, blood vessels cover each of the alveoli. So that's pretty tiny, pretty tiny. But it truly happens, oxygen coming from the alveoli go to blood circulation. We call it tiny small blood vessels. It's capillaries. And then carbon dioxide released from blood circulation to the alveoli. Because there are single line there, so they passing through pretty easily. So that happens every day for every people. Every day for every people. So that's the most important part for our life. So we say respiration is separation with three parts. Yeah. Still remember we're talking about from the beginning of respiration systems. We say respirations or respiratory have three parts. One part is pulmonary ventilation. Pulmonary ventilation, just coming from outside of the body, air going inside of lung, go to alveoli part. And then second part or second step is external or pulmonary respiration. So that's truly we're talking about the changing happens in the alveoli of the lung and the capillaries in the lung around the alveoli. So that's truly oxygen changing and the carbon dioxide changing. So that's the second part. That's the second part. So that we go back here. So when we're talking about the first step, first step, pulmonary ventilation. Pulmonary ventilation. So including still two parts. One part is inhale, inspiration. Means take air, go into the lung. Second part, exhale or expiration. Thus may basically relieve the air from the lung. So that's the air moving, go in and go out. So what's decided? They move in or move out. And that's basically it's kind of balance air pressure. So air pressure outside and the air pressure inside of the lung. Which side is higher? They will moving to a lower side. So how we can changing? So certainly we couldn't changing air pressure in the outside of the body. But how we can change the pressure inside of the lung? So that's basically by our respiration. Inhale, the chest cavity getting bigger and the lung getting bigger. Certainly pressure will be decreased. So the air going in. Exhale, the chest cavity getting smaller and certainly air of the lung getting smaller. Certainly the pressure will be go to increase. So the air flowing out go to outside of the body. So in that way, the air moving when like compare which side is low, will moving to which side. So that's our pulmonary or lung regulations. And look like we say it pretty simple, but truly, truly, it's a lot of things will affect it. We're talking about the chest. So around the chest, we have muscles. How it can working? Some muscles moving. And we also have some diaphragm. Diaphragm will be moving, will be increase the space inside the chest cavity. And we also be exhale. Basically, exhale is internal intercostal muscles will be working or contracted. And then moving the air go out. So that's basically some changing there. So that's the chest cavity increase in size and the pressure will be decreased. The chest cavity decreased in size, the pressure increased. So that's basically make our air moving in there. So that's basically during inhale and exhale and the muscles contractions make the air pressure changing. So that's why the air can go into the lung and relieve from the lung. But generally speaking, is the chest cavity is changing. When they decrease in size, the pressure will be increased, and then air go relieve from the lung to outside. If like increase the size is opposite, the air go into the lung. So that's generally speaking here. So picture here just show us some like muscles working during inspiration and expiration. So that's basically we have a lot of muscles and including the diaphragm. So this part we talked about in our anatomy already. Just quickly review here. So that's inhale. Inhale this side. The chest go to bigger, and the pressure go to lower. The air go in. That's exhale in this part. The chest cavity get smaller, and the air pressure increase. The air relieves. So that's inhale and exhale. Then we're talking about the second step. Second step. With the respirations, we have 3 steps. 3 steps. The first one, we just talking about air go into the lung. Air go into the lung. Like we talking about some muscles contractions and the chest cavity changing the size. So pressure changing. Then the air moving. Then second one, we call it external or pulmonary respiration. So that's basically we're talking about air changing happens between the alveoli and the blood vessels. So that's the second step. Second step. Then we see what happens in there. So just like this picture, just like this picture. So here is the heart. Mainly we talking about the blood coming from right side of the heart. Directly coming from right side of that's the atrium here, and then go to ventricle. Ventricle. So that's directly coming from right side of the heart, and then they connect it. We call it pulmonary artery here. Remember, when we're talking about the artery, we're talking about the blood vessels go away or bring blood go away from the heart. Don't care about the color. The color means how much oxygen inside of the blood vessels. So truly, right side of the heart, blood return back from the tissues. That's low oxygen kind of blood in there. So that's why it's blue color in there. This kind of low oxygen kind of blood coming from right side of the heart and go to the lung. And go to lung capillaries, means tiny, tiny small blood vessels there. So this direction. And we have a lot of alveoli here. So in this part, so basically we relieve carbon dioxide. We will talk about carbon dioxide later also. It's coming from tissues or cells metabolism. And they bring back from the blood circulation and reaching the lung air, and then relieve from the lung air. Still remember we talked about before. From high concentrated part to low concentrated part, the moving, material moving. And the small one, simple diffusion, that's the mainly way for gas. So simple diffusion here. And the same thing, oxygen, still coming from high concentrated part, go to low concentrated part. Still simple diffusion, still simple diffusion. So that happens in this area, if you try to compare some number here, you can see the oxygen's number coming back from the tissue is 40 here. And the pressure in the alveoli is 105. Certainly oxygen moving from 105 inside is 40. And the carbon dioxide is 45 in the blood circulation, but in the lungs still lower than it. It's about 40 there. So that's the moving way from 45 to 40. So we say simple diffusion. Yes, simple diffusion. Make the gassing moving from a high concentrated part go to low concentrated part. And now we have more oxygen in the blood circulation. So that's why we make the color right here, because it's rich oxygen kind of blood in here. But pay attention, these blood vessels return back to left side of the heart. We call it pulmonary vein. Just do the confusing here. This is the pulmonary artery. Even they are low oxygen kind of blood. This is the pulmonary vein. Even the high oxygen kind of blood. So we name artery and vein by it leaving heart or return back to the heart. We are not name it by oxygen levels. So that's basically the second step of the respiration. Then we go to the third step of the respiration. So basically that's the same picture because it is too bigger. I just cut to half and try to give you more clear explanation here. So this picture, the heart still in here, the same. Yeah, the heart still in here. Right side heart blood circulation go to the lung, and the left side heart receive the blood circulation return back from the lung. And from the left side of the heart, the blood bump into the big artery, aorta here, and then go to small artery, then sending to all over the body tissues. So here we're talking about in the tissue part, air changing. So blood vessels in the tissue part we call capillaries. Yeah, capillaries. Capillaries still remember from the artery, they have high oxygen kind of blood coming. Inside of tissue and the cells, the oxygen level is lower here. It's about 40. So it coming to the blood circulation, 100, certainly in the alveoli, is more than 100. We're talking about the last page, it's 105, but it's not totally balanced. Yeah, most oxygen go into the blood circulation, go to like inside pulmonary vein or alveoli there. They can reach about 100. Yeah, they can reach about 100. Then they sending. There are more than in the tissue and the cell. So still simple diffusion, oxygen moving to the tissue and the cells. And in the tissue part, carbon dioxide level is higher, 45 in there. So then So basically, you can see it's not that big a changing there. But still little bit higher compared with blood circulation. So they're still moving from the tissue to the blood circulation. And certainly, they continue generate some carbon dioxide. So that's basically we say the third step, the air changing, or we say respirations, 3 steps there. So certainly these kind of changing need something control, regulating. So regulating our heart rate, regulating how deeper, like the respirations, and mainly we maintenance internal cells oxygen levels, like how much we need and how much carbon dioxide we need to release. So we say inside the body, we have 2 control systems, but mainly control systems is the nervous systems. So basically, respiration control, they have control center. It located still in the medulla part and the pulse part. When we're talking about the breath, we separate the few parts, but the center part we call brainstem. So brainstem lower part is the medulla part, and a little bit above it is the pulse. And the nervous system's control is microelectrical in there. We call it microelectrical. It's nervous impulse. It's from medulla, it's from medulla part, but it's controlled by upper part in the pulse part. So that kind of regulations still negative feedback systems. We still have receptors. Inside the body, we still have receptors. They can receive the level of oxygen level inside of the blood. They can receive the carbon dioxide level inside the blood. And also acid level, like we're talking about the pH. And then, including the information they received, then sending information go to control center. And then negative feedback regulating. We say negative feedback systems, mainly maintenance internal environment balance, or we say homeostasis. So it can control the respiration rate, like make it go too faster. So you see some people do exercises, and after the respiration rate is increased, and their heart rate increased. So respiration rate increased, basically take more oxygen inside to the lung, and the heart rate increased. They make the blood circulation more faster and sending the oxygen go to the tissue, because when they do exercises, they truly need more oxygen in the tissue side. And they also can control how deeper of the respiration, and also control like a regular or not regular kind of respiration. So normally, the rhythm will be the same. But when people have sick or illness, maybe they will like not regular rate in there. Some typical example, like some people sleep and there's nothing, and then the respiration look like a stop there and suddenly coming. So basically that controls still negative feedback system because there's nothing and then there's no oxygen taken in, then stimulation control center, then got a big, deeper respiration, it follows. So that's still negative feedback systems and it control. So that's the location of our respirations control center. So inhale, exhale, they have different control center, but they are pretty close. That's medulla part. Below it is our spinal cord. And that's the pulse part. Yeah, that's the pulse part. So pulse part, we still have control center there. So that's generally for our respiration control. And we're talking about the receptors. Yeah, we say receptors, mainly we find inside of blood vessels, it's artery. Yeah. In the neck part, we have an artery there. And also inside of aorta, yeah, we have a aortic body there. And also we find it on the outside of medulla of the brainstem. They also have receptor there. Yeah. So these kind of receptors, basically, they receive the information, decrease the oxygen level. And also the information, increase the carbon dioxide levels and the acid levels. That will stimulations or respirations. So send the nervous impulse to the brain. So we have different receptors there. We talked about already. Yeah. And then sending to control center. And from the control center, sending impulse coming back to the lung, to the muscle, and helping to like take more oxygen and relieve more carbon dioxide. So that's basically our control. Yeah, that's basically control. So also, yeah, also some side spinal fluid also can have some changing. Also can have some changing, and also can have some balance control because it's changing. So that's basically about our respiration control. Then we're talking about the pleural cavity. Pleural cavity basically is around the lung. It's kind of air in there. So that's what we call pleural cavity. So it around the lung is the kind of air space. So they have one side directly attaching to the lung, another side attaching for the inside wall of the chest. So this space basically is negative kind of air pressure inside. So that means air pressure inside of the lung is higher than pleural cavity. So pleural cavity is working to helping the lung like maintenance inflated. So that's basically pleural cavity is working. Mainly working for the inhale. Mainly working for the inhale. So when the chest getting the space, chest cavity getting bigger, they directly pull the pleural cavity getting bigger. And the inside the pleural cavity is negative kind of air pressure in there. So that will be pull the lung getting bigger. So that's pretty important part for respiration. So that's something close relationship with or acupuncture or needling. We always say in the chest part or upper back part, don't put the needles too deeper. Too deeper maybe damage the lung. But truly, firstly, you damage the pleural cavity and you make the air go in the pleural cavity. When the air go in the pleural cavity, they will make the lung shrink. So they're not able to inhale for take more oxygen inside the lung. So that's make a severe kind of situation, certainly depending how big injury there. So small injury, maybe patient can recover like itself. But big injury, lot of the air go in, the lung shrinking. People truly pretty difficult breathing. And truly blood circulation, oxygen level will be decreased. So that's about pleural cavity. That's kind of protection part of the lung, but they mainly help with inhale and take oxygens.